For thousands of years, we have looked out into space and seen moons, planets, stars, and galaxies. But now astronomers have discovered that the universe consists of not only all the visible celestial bodies, there is also a very large amount of invisible matter out there. Mysterious dark matter.
We know today that only a small part of the universe is comprised of the visible celestial bodies, like stars, planets, gas, clouds, and galaxies. Stars emit light and planets reflect light, so they are visible and we can observe them. Dark matter is invisible, as it neither emits nor reflects light. But we can work out that it must be there, because it has mass and gravity. And this gravity affects how the stars are held together in galaxies and how fast the stars move around in the galaxies.
Gravity is very important in binding cosmological objects to each other. It is the mass of the Earth that attracts the Moon. Thus, it is the gravity of the Earth that holds the Moon in a stable orbit around the Earth. Similarly, the Earth is attracted by the Sun's mass, and we circle around the Sun due to the Sun's gravity. By observing how fast the planets move in their orbits, you can calculate the Sun's mass. We have had this knowledge for more than 300 years, ever since the time of Newton. But in 1932, a young Dutch astronomer, Jan Oort, was observing the movements of the stars in our Milky Way. The Milky Way is a spiral galaxy, and there are approximately 100 billion stars moving around in the galaxy. By looking at the spectra of the stars, he could tell how fast each star was moving. To his surprise, Jan Oort discovered that the stars are moving faster than they should, given the mass he believed there was in the Milky Way. Could there be something invisible, something he could not observe, some kind of heavy matter that was holding the galaxy together and was hidden from the astronomers? If there wasn't anything heavy, something that he could not observe, then the stars should be flying away from the galaxy. It is a bit like if you observe the Earth from space. You would see mostly water. As a result, you might suppose that the Earth consisted only of water. And then the Earth would weigh only 1/5 of what it actually weighs. From Newton's law of gravity, you can calculate how fast the Moon should move around the Earth in order to be in a stable orbit. This velocity depends on how much the Earth weighs, but when you measure the velocity of the Moon, you find that the velocity is much too great for the Earth to only consist of water. The explanation is that the Earth does not just consist of water, but there is also a lot of rock and land, and an invisible core of metal, which makes it heavy. This means that we can find out the mass of the Earth just by measuring the rotation speed of the Moon. In other words, we can measure the weight of an astronomical object without being able to see it directly. In the same way, there can be a lot of invisible matter in the universe that cannot readily be seen, but you can work out that it must be there. This is what we call dark matter.
In 1933, the Swiss astronomer Fritz Zwicky measured how fast galaxies are moving around in giant galaxy clusters. Galaxy clusters are large accumulations of up to thousands of galaxies. The galaxies are moving around among each other. Fritz Zwicky discovered that the galaxies are moving much too quickly, and he therefore concluded that there must be a lot of invisible matter in the galaxy clusters. He also called it dark matter. So by using the law of gravity, we've discovered that there is 5 to 6 times as much dark matter as there is visible matter like stars, gas, and planets. So we have known for a long time that there's something wrong, something is missing. But what is it? Astronomers have proposed 2 different solutions. Either there's about 6 times as much dark matter as there's ordinary visible matter, or there must be something completely wrong with Newton's law on large cosmological scales.
In 2006, there was a breakthrough through observations of galaxy clusters. The large galaxy clusters with thousands of galaxies are created when smaller galaxy clusters collide. These are violent events which take place at several thousand kilometers per second. By an incredible stroke of luck, some astronomers managed to take this image of a large galaxy cluster which had just collided with a smaller galaxy cluster. When you observe such a collision in the visible light, you just see the light from many galaxies. But in such a galaxy cluster, there is also a lot of hot gas, which radiates in X-ray. The gas between the galaxies weighs up to 5 times as much as the galaxies themselves. We can observe this radiation using special X-ray telescopes, and one finds that the gas is more than 10 million degrees Celsius. One also sees that the gas from the two galaxy clusters collide. In a galaxy cluster, one can simultaneously use the so-called lensing technique to measure where the heavy stuff lies. This technique measures where there is most gravity. The astronomers can now see that the things that weigh a lot are not located where the gas is. The main gravity in this galaxy cluster lies elsewhere.
From these pictures, we can conclude that there's a large gravitational attraction in areas where there's no gas. When you compare to other observations, you can conclude that Newton's law of gravity is also valid at intergalactic scales. The conclusion is therefore that there must be a lot of dark matter. The big question is then, what is the dark matter? From observations of the cosmic microwave radiation and from observations of the elements deuterium and helium, we know that dark matter cannot be ordinary particles. It cannot be any of the particles we know of. It must be a completely new kind of particle, one that we don't already know. The particle physicists who study the world at the atomic level have suggested a large number of possible candidates. Some of these suggestions are very imaginative.
One of the most discussed candidates to be the dark matter particles is a supersymmetric particle. The supersymmetric model suggests that every normal particle has a supersymmetric partner, and one of these supersymmetric particles could then be the dark matter. Another candidate for dark matter is a so-called sterile neutrino. It is a minimalist extension of the standard model. This sterile neutrino is similar in many ways to the ordinary neutrinos. It is only more massive. And if the sterile neutrinos are heavy, well, then they could very well be the dark matter. If the dark matter is such a sterile neutrino, then we need to look out into the universe in order to measure it. The model predicts that such sterile neutrinos decay every once in a while. And when they do, they emit a photon with a very specific wavelength. So astronomers are designing an improved photon camera that can observe the decay products from such reactions.
So we have two good candidates for what the dark matter could be: supersymmetry or the sterile neutrino. Right now, the scientists are looking for supersymmetric particles at the Large Proton Accelerator at CERN. According to CERN, they will find traces of supersymmetry over the next 3 years, if it exists. In this way, we're sure that at least one of these candidates may be experimentally rejected within a few years. And then there is, of course, also the possibility that something entirely different makes up the dark matter. But the future will tell. The research continues in the search for the answer to the mysterious dark matter.